Welcome to Olympiad Math for Year 3. This is Lesson 20, we'll learn tree planting problems Part 2. When solving tree planting problems, it is important to consider the planting route. If trees are planted along a closed path, the formula to determine the number of trees is, number of trees equals total distance divided by tree spacing. Additionally, some real-life problems can be solved using the tree planting method, such as cutting wood or climbing stairs. The key to solving these problems is to identify the relationship between the given conditions and the tree planting concepts of total distance, tree spacing, and number of trees. Example 1. A park pond has a circumference of 480 meters. If a willow tree is planted every 8 meters along the pond's perimeter, how many trees are needed? Regardless of the shape of the pond, the planted trees form a closed route. The number of intervals along the route determines the number of trees. The answer is 60 trees. A closed route follows the same principle as an open route where one end has a tree, and the other end does not. The key to solving this type of problem is to determine the number of intervals. Example 2. A garden has a perimeter of 1,500 meters. Cypress trees are planted every 6 meters along the perimeter, and a peach tree is planted between each pair of cypress trees. How many cypress and peach trees are planted in total? First, we calculate the number of cypress trees using the formula from example 1, 1,500 divided by 6 equals 250 cypress trees. Since a peach tree is planted between every 2 cypress trees, the number of peach trees equals the number of gaps between cypress trees is 250 peach trees. Now, please complete the total number of trees planted. Even though there are 2 types of trees, we first determine the number of cypress trees using the closed route formula. The number of peach trees corresponds to the number of gaps. Example 3. A group of 48 students forms a square for a game. There is 1 student at each corner. How many students are there on each side? Since each of the 4 corners is occupied by 1 student, we first subtract these 4 from the total. These remaining students are equally distributed along the 4 sides of the square. Finally, we add back the 2 students at each end of the side. The answer is each side has 13 students. First, identify that 4 students occupy the corners. Second, distribute the remaining students evenly across the 4 sides. Finally, ensure that the 2 end students on each side are counted in. Example 4. 3 logs are to be cut into 3 segments each. Each cut takes 3 minutes. How long will it take to cut all the logs? To cut a log into 3 segments, only 2 cuts are needed. Then we can find we need 6 cuts in total for 3 logs. Total time required is 3 times 6 equals 18 minutes. The answer is 18 minutes. Example 5. Villagers are planting trees around the village perimeter, which is 4,500 meters. A poplar tree is planted every 15 meters, and between every 2 poplar trees, 2 willow trees are planted at equal distances. Question 1. How many poplar trees are needed? Question 2. How many willow trees are needed? Question 3. What is the spacing from one willow tree to the next? The village perimeter forms a closed loop. First, determine the number of poplar trees. 4,500 divided by 15 equals 300 poplar trees. Since 2 willow trees are evenly spaced between every 2 poplar trees, the number of willow trees is 300 times 2 equals 600. Next, find the distance between 2 willow trees. Because 2 willow trees are evenly spaced between 2 adjacent poplar trees, which are 15 meters apart, the distance between adjacent willow trees is 15 divided by 3 equals 5 meters. When separated by a poplar tree, the distance between these two willow trees is 5 times 2 equals 10 meters. The number of trees planted along a closed route follows the same principle as an open route where only one end has a tree. The key formula is number of trees equals total distance divided by tree spacing. Example 6. A father and son are climbing a 300-step slope. The father takes 3 steps at a time, and the son takes 2 steps at a time. If they both start at the same point and shared steps are only counted once, how many total steps do they step on? First, we find the son's steps are 150, second, we find the father's steps are 100. Then, we can determine the shared steps, where both step on the same step is 300 divided by 6 equals 50. Finally, we find the total distinct steps, which is 150 plus 100 minus 50 equals 200. Solve this problem in 3 steps. First, calculate the number of steps the son takes. Second, calculate the number of steps the father takes. Third, remove the overlapping steps that both stepped on. Here are the practice problems for today. Thank you for watching and hope you enjoy your math today.